It's another edition of the Physics Friar, now presenting to you Momentum. Golf ball, Mount Carmel, probably has about a mass, I'd say of 0.1 kilograms. Let's say 100 grams. And this is really heavy weight with a mass of 35 pounds and let's see here, 15.9 kilograms. I have it upside down. 35 pounds, 15.9 kilograms. First question for you, which has more inertia? If you answered that the 35-pound weight had more inertia, you are correct. Objects that have more mass have more inertia. They're harder to get moving, they're harder to stop moving once they get going. However, what about this now? In this situation, which object, the weight or the golf ball, has the greater momentum? If you answered the golf ball, you were correct, because momentum is basically inertia in motion. An object at rest has no momentum. However, an object in motion does have momentum. For example, momentum. Physics often defies common sense about how the world works, but this is actually quite common sense. Have you ever heard the phrase, he's got a lot of momentum? If you have heard that phrase, then you already have a kind of an intuitive common sense idea of what momentum is. Let me give you an example. Picture the biggest guy on the football team. Let's call him Bob. Okay, Bob is the biggest guy on the football team. And Bob is running at you at full speed, right? Okay? Bob has a lot of momentum. You're going to want to get out of Bob's way. Now take a fly, okay? And this fly is buzzing at you at the same speed. I mean, it's gunning right for your face, okay? But it's not as much of a problem. Why not? Even if it's going the same speed as a football player, you know it's not going to hurt as much if it hits you. And the reason why is because the fly has much less mass than Bob, okay? Less mass, less momentum, given the same speed. But wait, what if the football player is just sitting there? Alright, not moving around at all. And that fly is still going for you. Okay, which has more momentum now? Well, the fly does. In fact, if the football player isn't moving, he doesn't have any momentum at all. Only moving objects have momentum. The idea is basically that momentum is inertia in motion, right? Okay, this object, okay, well, not object, this is Bob. Bob has much more inertia than the poor little fly. But if Bob isn't moving, if Bob is just sitting there, then Bob has no momentum, okay? Objects have to be moving in order for them to have momentum, because momentum is a property of moving things. Let's say they're both moving, football player and fly moving at the same speed. The question you ask, which has more mass? In that case, the object with more mass for a given speed has more momentum. But if the football player is just sitting there and the fly is buzzing around, the question that you ask is which has more speed? Momentum, basically, the point is, it depends upon both the mass of the object and its speed. The faster you go, the more mass you have, the more momentum you have. Common sense, right? So the physics definition of momentum is mass times speed, or mass times velocity if we're bothering about direction, right? Remember that velocity is like speed that's gone to college and gotten some more information. Specifically, it's gotten some direction, and now it's graduated to velocity, right? You watch Indiana Jones and Raiders of the Lost Ark. I used to love that movie as a kid. In the beginning of the film, Indy's got to get out of the way of a moving boulder. And here's the physics behind Indy's fear of the boulder. A moving boulder has more momentum than a stone rolling at the same speed. So if you just take a little pebble and it's rolling along, you're going to worry more about the boulder if both of them are rolling down a hill at the same speed. Additionally, a fast boulder is going to have more momentum than a slow boulder. If that boulder is just kind of rolling along, at 1 mile an hour, it still has some momentum, but you're much more worried about the boulder that's rolling down the hill at you at 90 freaking miles an hour. Oh, but then finally, you wouldn't be worried at all about a boulder just sitting there at rest. A boulder at rest would have no momentum, right? Because if momentum is mass times velocity, and the velocity or speed is 0, mass times 0 equals what? 0. The momentum would be 0. Check out these questions now. So a moving object has A. Momentum, B. Energy, C. Speed, or D. All of the above. Pause the video now and decide your answer. What'd you pick? All of the above. Right on. You're entirely correct. We'll see in the next chapter that there is something called kinetic energy, and that's energy in motion. Alright, how about this one? When the speed of an object is doubled, its momentum remains unchanged in accord with the conservation of momentum. It doubles, it quadruples, or it decreases. Can you answer that question? Pause the video. Select your answer. If you picked D, you're wrong. Correct answer was B. Doubles. The momentum doubles when the speed of an object is doubled. That basically does it for momentum. But I almost forgot the answer to the riddle. Which has momentum? Alright, there's that semi-truck there, and there's that girl on the tricycle. And the riddle was, would you rather be hit by a stationary semi or a 5-year-old girl riding a tricycle? What does stationary mean? It means that the semi is at rest. Its velocity is 0. If its velocity is 0, it doesn't matter what its mass is. It could have the mass of the Earth, and its momentum would be 0. Whereas if that little girl is riding the tricycle along, even at 1 mile an hour, she's got more momentum than a stationary semi.